Hello everyone, I am Soumyashree Senapati, Assistant Professor Vedang Institute of Technology. In this class, we will discuss compound stress. In our previous classes, we have already discussed about different types of stresses, but we have learned in our last types of stress that biaxial stress with pure shear. Now, we will learn what are the compound stress. Before going to compound stress, what is stress? Stress is, we can know that stress is internal resistance capacity of any material, right? So, internal resistance capacity of a body is termed as stress. Also, we can say stress is our force upon area, right? So, here what is compound stress? Compound stress is like if in a body there are normal stress and shear stress present in normal stress and shear stress, we will term that as compound stress. Okay. So, let us, we are taking this body as A, B, C, D. Okay. So, we can say if like there is any stresses acting perpendicular to the structure. Okay. So, we will term that as normal stress. If any stresses acting perpendicular to the structure, that will be what? Our normal stress. Okay. Also, likewise, if the stress is acting parallel to the surface, that will be our shear stress. Okay. Shear stress always acts parallel to the body. We need to remember these things. If any stresses acting parallel to the surface or to the plane, you can say that as what? As shear stress. Okay. So, here what? Our normal stress and shear stress. So, we know what is normal stress and shear stress. If in a body like here in y direction there is a stress, we will term that as sigma y, and in x direction there will be sigma x. So, in case of any body, if there is presence of more number of stresses, so there will be one what? One is maximum stress and another is minimum stress. Okay. If in case of any body there is presence of tau, but tau value is 0, that is our shear stress is 0. So, as in our previous classes we have already discussed that if in case of any body there is the shear stress becomes 0. So, we will term that as principal plane and the normal stress will be principal stress. So, if there is two numbers of principal stresses, one will be maximum principal stress. Okay. One will be maximum principal stress, another will be minimum principal stress. Okay. So, we will discuss those maximum principal stresses, minimum principal stresses in our next classes, but now we will discuss how these compound stresses formed. We will do some one 3D diagram And next we will here we will draw sorry here we have the ABCD block. Okay. Here. So, as our stress is acting in 3 directions, so we need what? We need a 3D diagram to show perfectly those. Okay. Here. Here we got the block. Now we can do this like in dotted. Yes. Here. We have A, B, C, D block. Okay. So, now we will see how compound stress is formed. As we can see in this A, B, C, D and you can name it as E, F, G, H block, we have 3 phases. Okay. Our stresses works in X, Y and Z directions. Okay. Also, we have here our X plane, Y plane and Z plane. You can term it as X phase, Y phase, Z phase, there is no issue. Okay. So, now what? In X, Y, Z plane, how this works? Like we can see here, this X direction will cut this phase. Okay. If this X direction goes like this, okay. So, what happened now? Here as X direction goes like this, the direction that cuts which plane will be termed as that plane. Like if X direction cuts this plane, so this CGHD or DCGH will be your what? X plane, right? Likewise, here Y direction will cut ADHE plane. So, ADHE plane will be your Y plane. You can write it here. So, our X plane will be what? CGHD and our Y plane will be ADHE. Okay. And here Z plane, that will be here. You can see this is cutting like this. So, the face, front face will be our what? Z plane, A, B, C, D. Now, we have our 3 planes, X plane, Y plane and Z plane. Now, we will see one by one how these forces or stresses works. Okay. So, first we will take X plane. Okay. In X plane, as I have already told you, like here one normal stresses will act in X direction. Okay. So, we will term that as sigma xx. Okay. Here we will term that as sigma xx. Why sigma xx? As these stresses acting in x plane, that is why sigma x, and in x direction, that is why sigma xx. Okay. So, due to this normal stress, there will be another two shear stresses will act. Okay. So, the shear stresses will act like one in y direction and another one in z direction. Okay. So, we can name that as sigma xy, sorry, tau xy and tau xz. So, in x plane, we have normal stress as sigma xx and what? And our shear stresses as tau xy and tau xz. Okay. We are naming it like, if in case of this x is used for as the stress is acting in x plane, and for y as the stresses is acting in y direction. Okay. So, likewise, we will find out stresses in y plane. Okay. So, in y plane, like this will caught this plane. So, we will have one normal stress and two shear stresses, right. So, we can name that as sigma yy, tau yz and tau yx, right. Why sigma yy? Like this stress is acting in along y plane and along y direction. So, in y plane, or you can say in y face, okay, the normal stress we get is equals to sigma yy, then shear stresses are what? Tau xy, sorry, tau yx, tau yx and tau yz. Okay. Tau yx and tau yz, we use this suffix because of along y plane and x direction. Here along y plane and in z direction. Okay. So, likewise, we will find out in z direction, in z plane also. Okay. So, here in z plane, we will have one sigma zz, sigma zz and two shear stresses, that will be tau z y and tau z x. Okay. So, we can write in z plane what? The normal stress is, you can write sigma zz as zz for what? In z plane and in z direction, and the shear stresses are what? Tau z y and tau z x. You can say that tau zx and tau xz are same, but no, this tau xz and tau zx are not same. Okay. Why? This x we use as it is in x plane. Here zx we use as it is in z plane, but there will be similarity, but their sign will be changed. I will say those informations while we discuss sign convention. Okay. So, till now this tau zx and tau xz are different. There will be the changes of their sign. Okay. So, now we have now we have the stresses in x and x, y, z plane. Okay. So, we can write it in matrix form. So, we can write it in matrix form as first sigma xx, sigma yy and sigma zz, tau xy, tau xz, tau yx, tau yz, tau zx, tau zy. Okay. So, in matrix form, we will have the stresses like in this way. Okay. So, here we have our normal stresses, right. So, also we can say these are of x phase, these stresses are for y phase and these are for z phase. Okay. So, in the matrix form we can write these stresses like this. While we have the values of stresses by matrix, also by using matrix we can solve this. Okay. So, now we will understand sign convention. To know about sign convention, we need to draw one simple rectangle shape object. Okay. So, first we will understand about normal stresses. As we have already know about stress, we are like we have already studied that in case of tensile stresses, here we will have positive sign. Okay. And if there will be compressive stress, then we will have negative sign. Okay. Fine. Like this will elongate the body and this will contrast the body. Okay. So, we can write it like if we have tensile stress, then we will use positive sign, and for compressive stress we will have negative sign. Okay. So, we have studied about what? Normal stresses. Now, what? Now about shear stress. As in case of normal stress, there are tensile stress and compressive stress. So, we can easily differentiate it with positive and negative. In case of shear stress, what we will do? So, in case of shear stress, we have already seen that it will act parallel to the body. So, if here one shear stress is acting, so what happened? So, we will name it as it is in what? It will be in y plane and x direction. So, it will be our tau y x. Okay. So, the direction is going like this. So, another will be, this will be also tau y x, but in opposite direction, right. Now what? If in this direction, sorry, here, if in this direction one stresses will be act, so we will name it as tau x y, as it is in x plane and y direction. So, this will act in this direction. So, another force here, the another stress will act in this direction. This is also your tau x y, right. So, we can differentiate it positive and negative by clockwise or anti-clockwise direction. Okay. Clockwise direction. We can see this tau y x is going in anti-clockwise direction. It moves in anti-clockwise direction. So, for anti-clockwise direction, we will take negative sign. Okay. And here we can see this. This is moving. We will change the color for better understanding, like here. This is moving in this direction. So, this is going like our clock. So, here this will be clockwise direction. So, for clockwise direction, we will take positive sign. Okay. Now, we have understood sign convention better, like for tensile stress we will take the positive sign, and for compressive stress we will take the negative sign, and for clockwise direction we will take positive, and anti-clockwise direction we will take negative. And if this is moving like in this direction, so this will be the opposite direction. Here if in this direction, this will be opposite direction. Okay. So, always this tau yx and this will be same, right. There will be no change of values in this and this and this and this, right. So, we have understood the sign convention, and here the matrix form, how to form the matrix of a compound stress. Okay. And the stresses, how to know the stresses in which plane it is acting, like this. So, in this class we have completely understood about compound stresses. If any doubt, you can ask it in comment section. So, in our next class we will understand Morse circle. Okay. The analytical and graphical, there will be differentiate between analytical and graphical representation and all. So, thank you so much.